Hello and welcome everyone to the introduction to Google Cloud Platform. So I'm going to set up some agenda for today's course. So we are going to start with understanding what exactly is cloud computing, why do we need cloud computing, what are the different cloud services and different providers that we have. It's always the same thing, right? If the moment we have a product, there are different vendors for that particular product. So cloud computing is a product and there are different vendors that are serving this particular product. Then coming to the main part of this particular agenda, like what exactly is GCP and why GCP? Because as I said, there are different vendors present right now. So why should I go for GCP? What are the different GCP services that we have? What are the different regions and zones that GCP covers? And I'm going to give you a short demo on how to create a virtual machine on GCP. Great. So what exactly is cloud computing? So this is the definition that we have right now, like what exactly is cloud computing? Okay, cloud computing is the on-demand delivery of compute power, database, storage, and other IT resources through a cloud services platform via the internet with a pay-as-you-go pricing. All right, so this is just the definition. We are not here for the definition. I'll help you out to understand it in a simpler way. So to give you a clear definition about what exactly cloud computing is, I always give this particular example. You guys have a laptop and your laptop basically has a, I'll switch on to my whiteboard. So you guys have a laptop. All right, your laptop has a storage, your laptop has an operating system, your laptop has a disk, your laptop has network. So this is the laptop that you guys are having. The reason I'm giving example here as a laptop is because this is the day-to-day thing that we are dealing with instead of servers these days. So what cloud computing exactly is, we have divided, what we have done is we have simply divided all these services and all these aspects into different services. So now you have storage as a service, operating system as a service, disk as service, network as service. And what we have done is we have given it as a name as cloud computing. And what we are doing is we are using internet, basically the internet that we guys have, as the medium between us, the user, and the cloud to deliver these services. That's it. I mean, it's good that if you guys remember the definition, but if in case you need to make cloud computing easy for somebody else to understand, just give them this example that anything that you have on your servers or anything that you have on your laptops, if it is broken down into different parts like storage, operating system, disk, network, and the same aspects are being delivered via internet as services, that is cloud computing. All right, wonderful. I'll switch back to the slides now. We have just understood what exactly cloud computing is, and now it's important for us to understand the different flavors of cloud computing that we have at this point in time. I know, I mean, this particular cloud services diagram that you guys see right now, you must have seen it like multiple times, when you Google what is infrastructure as a service, what is platform as a service, what is SaaS. But just to understand it in a simpler way, I'll make it very simple for you guys to, keep this in mind. So as I said, on the left-hand side, you can already see that we have a on-premise, on-premise server. Instead of, if you're not able to imagine a server, just imagine it this way: you have a laptop. What are the different things your laptop has? Your laptop has storage, your laptop has networking, it has operating system, it has middleware, it has runtimes, it has your data, it has your applications, and definitely there might be some users who are using virtualization who are not. So virtualization and server is key here. I mean, this is not part of laptop, but I'm just making it easy for us to understand it. So yeah, so if you keep in mind what are the different aspects your laptop or your server has are like networking, storage, servers, virtualization, operating system, middleware, runtime, data, application, everything that you see here is being managed by you. I'll give an example. I own a company, and let's say this is like 20 or 30 years back. I need to buy my own servers, okay? And these servers, I need to install my own operating system. I need to install the middleware, the runtime, the applications that I need, all right? If I need virtualization, I myself need to take care of that. I need to take care of the networking aspect. I need to take care of the data aspect of the users or the application. Everything has to be managed by me. Now, coming to infrastructure as a service, what exactly happened with infrastructure as a service is, so everything that you see here in red, this particular part, the networking, the storage, the servers, and virtualization. So this is being taken care by the vendor that you're using as a cloud computing. So for example, in our case, if we are going to use Google Cloud, so virtualization, server, storage, and networking is going to be taken care by Google here. And the only thing that you guys need to worry about is your applications, your data, might be your user data, application data, your runtime, like your middleware, whatever the middleware, and your interested OS. So OS, when I say be clear, it's Windows and Linux. Do not have an assumption that you can even go ahead with a Mac OS. No. So we have a limitation with OS that are being currently supported is Windows and Linux. That is market wide being used right now. Compute engine is something from the Google perspective that is called as infrastructure as a service. Why? Because you have control on installing your own OS. So you will install your own demo. You have control over the runtime, the data, the applications that you're willing to run on that particular compute engine. But the virtualization aspect, the server aspects, the storage, the networking is going to be taken care and managed by Google. You don't have to manage it. So there's the difference, okay? Moving on to the platform as service. So here you see that only application and data is in green. That means this is the only part that you can maintain if you're using platform as a service. The rest is going to be managed by your vendor, which is this is what is different from platform as a service. So here even the vendor is going to take care of the operating system, the runtime, the middleware, everything. You just bring your code, run it, you take care of the applications and the data that your code is generating. That's it. Great. Moving on to software as a service is the most simplest one. Anything on the internet, any application that you are using on the internet, you do not have control of that. All right. So whether it's your data, whether it's your application, you don't even care about what operating system these guys are using behind. You just want to run your application, get the work done out of that application. The reason why am I saying application here is I just want you guys to think about an example of software as a service. CloudWatch. Let me clear this. Here's all drawings. Various cloud providers. Okay. So as I said, with a product comes different vendors. For example, we had the first bike in XYZ year, then came Hero Honda, then came Kawasaki, and all the big bikes, the big companies jumped in and they are trying to improve the bike business, the two-wheeler business out there. The same thing comes with the cloud providers. So we had cloud computing, and then after there are different players coming in. They are all trying to improve the cloud business. They are all trying to, bring challenges in so that, they can challenge each other and improve the business. So there are different vendors like DigitalOcean, VMware. The most common you must have heard is AWS and Microsoft Azure. So these two have the highest, market capacity right now. They are being capturing the most of the market, Amazon Web Services and Microsoft Azure. But the one that we are, mostly interested right now is Google Cloud Platform. So even Google Cloud Platform, I'll give you a brief history. It started in the year 2007 with just one service, and then after what they were actually doing is they were giving their services on the Google Cloud Platform to their own developers and trying to improve their business. And eventually when they realized that okay, these are something great services that they can put in for the market for others to use and take betterment of it so that everybody can use. So that's what they have done. So these are the different cloud providers. Moving on to our next slide. Why Google Cloud Platform? All right. So all we know right now is Google Cloud Platform is a suite of cloud computing services. They are going to provide us with different infrastructures, different services, compute engine services, storage services, networking services, security and machine learning. There are different services that are present on Google Cloud, and Google Cloud Platform is the cloud computing service being provided by Google. The question comes, why Google? So as I said, in the last statement that Google Cloud Platform started in the year 2007, and then after these guys were internally building it, once they made sure that okay, their Google Cloud Platform is working great, and they wanted to share this idea with all the other individuals out there so that they can also take benefit of these services that they have made. And with Google Cloud Platform, I always say one thing: this is battle tested. When I say battle tested, what it exactly means is they have tested their own services on their some of the great products like Google Search, Gmail, Google Photos, and YouTube. So we all know about these products. We are using it in our day-to-day life. So something that has been tested on these frequently used products by worldwide, we can imagine the strength that these products has and these services has, and the amount of security that these services will have. Okay, so that's why it's important for us to understand the security aspect involved with Google Cloud Platform. All right, so Google Cloud is cost effective. When I say cost effective, why? There were different players in the market like Azure and AWS. Everybody was charging, the compute engine resources for like per minute. So there was nothing as per second. But when Google came into the picture, it started charging per second. So Google was the first compute platform that started taking charges for per second, which changed the game. All the other vendors made sure that, oh, okay, now we have a competitor here who is challenging per second. So it's important for us to go ahead and consider this as per second. And they also changed their business. With cloud computing comes high scalability. That's one of the feature. All cloud computes have, all the cloud computer vendors like Azure and AWS has. But with GCP, we already know, as I said in the previous example, GCP is battle tested. It has YouTube, it has Gmail, it has Google Photos. So they have like millions of users, worldwide, and they know their business and they know exactly how to scale a server. They have done that like I don't know how many times, but they are doing it for like more than 10 years, 20 years, for more than decades they have been doing this. So they know the scalability business very well. So it's highly scalable across the different regions that Google Cloud has. So you have custom machine types. I'm going to give you an idea about custom machine types when we are going into the compute engine. We are going to discuss about this custom machine types in detail. Basically, custom machine types, I'll give you an example. So when you try to create a compute engine resource on Google Cloud, you have different machines already available. Like it could be general purpose machine, it could be memory optimized, it could be compute optimized where you need a higher amount of compute resource, and there could be another machine where you need a memory optimized resource. So these machines are already by default given to us by Google, but there are some users who are willing to create their own custom machine. So let's say I'm not comfortable with having 4 GB of RAM on my machine. I want to have 6 GB. I'm just giving an example. I want to have 6 GB of RAM, but after 4 GB, what Google has is 8 GB. So I'm going to create my own custom machine with 6 GBs of RAM in it. All right. So that's custom machine types. Coming to Internet of Things. So this is a big thing that Google is working and has been working a long time ago. All the other cloud vendors are also working on it. They are trying to make sure that any technology that is out there, they can deliver it as a service. That's it. Same goes with different APIs and ecosystem that they have. They have their own APIs. Anything that you see as a service has its own API, so that you can simply integrate it with your own code and create better apps and take leverage of Google, all the services Google Cloud Platform gives us. Big data, another booming word, or another buzzword I should say. Big data is nothing, it's just that a huge amount of data that is being used, and the only thing that Google Cloud does it, they know how to manage big data and take out the important information or analyze the important information using big data analytics. So they, as I said, in the scalability, they know the analytics business. They have been doing it for decades with search, with Google search. So they know the analytics business very well. Cloud AI, so artificial intelligence, they have their own artificial intelligence APIs in the market right now, and these are serverless. When I say serverless, it does not mean there is no server in the behind. It's just that as a user, you are not going to take care of those servers that we used to do in in the on-premise setups. So this serverless is just to make you understand you are not taking care of those servers. Is somebody else here, I mean in Google Cloud is Google, and if you have AWS or Microsoft Azure, so it's Amazon and Microsoft respectively. All right. Moving on to our next slide. What is Google Cloud Platform? We already know by now what exactly Google Cloud Platform is. It's the cloud computing infrastructure or the service provided by Google to the end users. That's it. This is the definition. If you guys are interested, Google Cloud Platform is a suite of cloud computing services and management tools offered by Google. I always encourage to understand the understand the technology or understand the meaning behind any definition, and that way it is easy for us to understand. We already know what exactly cloud computing is. Always try to understand it with an example of a laptop, and same thing goes with what exactly Google Cloud is. It's a cloud computing service, all right, that is being provided by Google. All right, so here's the slide which is going to talk about the different services Google Cloud offers. This is, I'll be very honest, this is just a part that you are seeing right now here on the screen, because if I go ahead and try to put all the services that Google Cloud Platform has at this point in time, I'll have to put in, I don't know, like hundreds of slides just to show you guys the services. So these are some of the major services, the big players, that being used by all the other vendors out there. So it has its own compute, storage and database, networking, big data, different developer tools, management tools, cloud AI, Internet of Things, identity and security, and one of the most important, I would say, is data transfer. Why I said it as important? Because we have users on premise, we have users on other public cloud, and if somebody is interested to move to Google Cloud Platform, Google has their own data transfer, and trust me, it's one of the most simplest and the easiest way you can move your data to Google Cloud Platform that I have seen recently. It's wonderful. Okay, we are going to discuss about these services in brief. I mean, the time does not permit me to go in detail, but I'll definitely discuss about these services in brief. All right, different GCP regions and zones. So don't go by the regions and zones that you guys see right now here. All right, this is consistently changing and evolving. There are new regions and zones being added every month by Google. They are doing that. Trust me. I mean, if you go ahead and try to Google out GCP regions and zones image right now, you're going to see a different image. So yeah, this is something consistently being changed. So they have presence more than, I don't know exact number. They have presence in multiple continents right now, and I guess that they have some zones created in here as well, but I'm not sure about it. But yeah, you can go ahead and definitely take a look onto the regions that Google Cloud has right now. Okay, so just to understand what exactly global resource and a multi-regional resource is. So global is something that is worldwide. Okay, so let's say my global resource is, as you can see, is BigQuery and data store and cloud storage. That means I can have a cloud storage here in, okay, let me just clear this. I have a cloud storage here in India, and I also have a cloud storage in, just an example, America, and my end user simultaneously can go ahead and store whatever he wants in India, whatever he wants in America. So when I say cloud storage, it's multi-regional, it's a global resource, right? You can go ahead and use it in multiple regions or different global locations that Google has right now. Same goes with BigQuery and data store. With regional resource, it's App Engine. So if I say what exactly App Engine would mean is, let's say you have a code running here in India on App Engine, you have your code running here on App Engine. Don't expect that you can go ahead and make sure that you have high ability setup, or you can just make sure the scalability is done in a way that one server spins up in India, another one spins up in America. No. So even if the scalability part has to be taken care, it has to be done in India. So you need to make sure you understand the regional aspect as well as the global aspect of GCP. Then comes zonal. All right, so in India, so the reason why I'm giving example of India is, I guess it would be easy for all of us to understand it. So let's say I have a zone here in Mumbai, I have a zone here in Delhi, and Hyderabad. Okay, so this I'm pretty sure these are the different zonal resources. Sorry, the zonal locations that in Google Cloud has right now in India. So if I say I'm going to create a VM instance here, don't expect that particular VM instance to automatically scale in a region or in a zone which is different than Mumbai. You cannot expect a VM running in Mumbai to scale in a zone running in Delhi. No, that cannot be done. So just understand VM instance or compute engine instance is zonal resource, app engine is regional, BigQuery data store, cloud storage, these are something global resources or multi-regional resources. All right. Okay, creating a GCP account is very simple. You can simply go ahead, console.cloud.google.com, and you will be logged in. You will be started with a page which is going to give you an option to log in with your existing account, or if you do not have an existing account, you can simply go ahead and create a test account, and that particular test account is going to give you around $300 to be spent over a period of 12 months. So good amount of money for practicing, and good amount of time. I would say 12 months is great time. Just make sure that whatever the resources that you are creating, you shut down them or you stop them and delete them once you are done with that, or else it's going to charge you money. If that's what is cloud all about, you pay as you go. So if you're going to use something that is running as a resource on your cloud account, you're going to pay for it. Just simply shut it down or stop it. Okay, this is the home page of Google Cloud Platform. All right, so on the left hand side you can see the home button. It has all the options from cloud launcher, from the billing, from support, IAM, everything mentioned here. And along with that, it has compute mentioned. So in this particular screenshot, you can just see the compute aspect of Google Cloud Platform right now. This is the dashboard. It's going to give you information about what are the different projects that you are running. In case you are running multiple projects under the same account. Okay, under the same account, if you are running multiple projects, then you're going to see that project name, the project ID, the project number. All right, you'll also see different resources that you are running under that particular project. In this particular screenshot, we never had anything running, so you do not see any resources. You will see the API request. And another thing, do not panic if you do not see it in the same way, because this is consistently changing. All right, so this is consistently changing. I just want to be very clear that do not panic on that part. Okay, it's changing, it's evolving, they are trying to make it better every day. Here comes the interesting part that I was talking about, the GCP services in depth. All right, I'll request you all to pay a lot of attention from here on now. All right, because there are different services that I'm going to cover, and these services are tricky when you try to understand, because they have minute or major differences in between them, and it's important for us to understand those differences. Okay, all right, so starting with the compute part. So this is one of the service that Google Cloud provides. All right, so it has a compute engine. So when I say compute engine, you can simply go to your Google Cloud and spin up a complete virtual machine. A virtual machine that has its own database. Okay, it has its own RAM. Everything is going to be taken care by you. So when we were discussing the different flavors of cloud computing, I said this is infrastructure as a service. All right, so here you are going to take care of your application. Here you are going to take care of the data generated by that application. Okay, your operating system, you are going to take care, and you are going to make sure what operating system you want, whether it's a Linux, it's a Windows, whatever you want. So why compute engine? There might be a question coming to your head that, okay, we are talking about Google Cloud or all the cloud providers being serverless, they are being maintained by the vendors, then why are you asking me to go for compute engine? I'll give you a simple example. There are situations which I came across, while helping our customers to move to clouds. There are some applications, legacy applications, which cannot be made cloud ready. You cannot simply put them on an app engine, or you cannot, simply containerize those applications. And that at that point in time comes compute engine. Compute engine basically gives you a virtual machine. For example, on my on-premise, I had a virtual machine with 6 GB and XYZ processors and everything. I can simply go ahead and create the same compute engine machine on Google Cloud and then move my application. Along with that, there is more control given to me. If you go to the previous slides we had in infrastructure as a service, I had more control on what exactly is running on my particular virtual machine. So if that's the requirement, I would always suggest you to go for infrastructure as a service, and in Google's case, go for compute engine. Now comes app engine. So app engine is basically, understand it this way. I gave you an example. My code is not cloud ready, so it's a legacy code. So I'm going to use compute engine. Now I have an application which is running on premise and which is cloud ready. I can simply move it to cloud. Okay, and I do not have anybody in my team who knows GCP, but they just know few here and there parts of GCP. So they said, hey, you know what? Let's go ahead and spin up app engine, and we can simply dump our code onto that, and everything will be taken care of by Google as a vendor. So there comes App Engine. This is platform as a service. This is going to give you a platform to be used to run your code. So you just bring your code and you take care of the data generated by that code. That's it. Your application and your data. That's it. Nothing else has to be taken care by you. All right. So this is container engine. Another warning that I'll, not a warning, but another pointer that I like to give you guys is, if you do not see container engine again on Google Space, so this is now known as Kubernetes engine. All right. And this particular container registry, so they have changed it to Cloud Run. So don't worry. I mean, the functions remains the same. It's just that they have given some new improvements and new names for all these services. Okay. All right, wonderful. So the container engine, the simplest and the easiest example is, now it's known as Kubernetes engine, and the reason why it's called as Kubernetes now is, if you have an application which you are running on Kubernetes or on Docker or anything that any containerizing, you have containerized your application and you want to run it the same way on your cloud, on Google Cloud, Kubernetes engine is your answer. Okay, whatever you do on your Kubernetes on your on-premise can be done on your Google Cloud platform. So this is called as Kubernetes engine. It was, the container engine was an old name. Okay, coming to container registry, Cloud Run. So if you have a web application, all right, if you have a web application that is running, and you also want to make sure that you are able to take the benefit of containerization. Okay, if this is something that you are looking for, okay, Cloud Run is your go-to guy. Okay, so Cloud Run, you need to use Cloud Run only when you have a web application. Could be anything, like you just got in, you created a website, like a commerce website, you're selling your products very well, you want a website to be hosted on compute on Google Cloud platforms, go for Cloud Run. Cloud Functions, very simple. Cloud Functions is something as, these are event triggered. Okay, so let's say I don't want to run my code consistently, because any cloud computing is pay as you go. So if you're going to run your code consistently, even if your end users are not using it, you're going to be charged for it. Then comes Cloud Functions. So let's say I have an e-commerce application. I just need that code to run when my customer or when my end user adds an adds a let's say you are an e-commerce application and you are adding a good to your cart. Okay, the moment somebody adds a good to that particular cart, or you add a product to that particular cart, only at that point in time I want my code to run. So if that's the scene, you can go ahead and have Cloud Functions being installed there, and you can use Cloud Functions to run your code. So I'll repeat, don't be confused. I know these are very confusing terms and confusing explanations here, but just understand it this way. Cloud Function is something, if you don't want your code to run consistently, you just want your code to be triggered only when there is an ask. At that point in time, you need to use Cloud Functions. Okay, all right, I'll have to move on to my next slides here. Networking. So Cloud Virtual Network is the VPC, virtual private network, that Google Cloud offers. Basically, you can create your own network and segregate your machines from different aspects. Like if you want a network for your production environment, you can go ahead and create your own VPC. If you want a network for your particular virtual private cloud on test machines or test users, you can have their own different VPCs. Okay, that's VPC. Basically, it's all the networking aspect. It has different flavors. which is the default VPC. Default VPC is basically going to have your networks created in all the regions by default. As the name says, by default it's going to create your different regions in all the create your network in all the regions. It has a auto VPC as well as a custom VPC. Most of the time we take care using the custom VPC because we don't want unnecessary networks to be created in different regions or zones, right? We don't want that. So we want specific zones or regions to be allocated as our VPC networks. That's what in production we do, but for the testing purpose, you can definitely go ahead and create a auto VPC, create machines, play with that and learn it, okay? Cloud load balancing this is a load balancing solution given by Google Cloud Platform. So they have, simply to understand it, they have regional and global. So global is something you can use universally in all the global locations that Google Cloud Platform offers. It could be HTTP load balancer or HTTPS load balancer. It could be a SSL proxy if you need. Okay, it could be your TCP, UDP, cloud functions are like workers. Okay. Okay, so this is your cloud load balancing. Coming to cloud CDN, it is part of your cloud load balancing. How? Let's say I have a end user. Just focus here on the diagram that I have here. So let's say this is my end user here. He's trying to reach out to a particular machine here. So he has to go through the complete load balancing, okay? And this process is going to cost us some seconds, okay? So Google even take care of those seconds. So what it does is, let's say this particular user who is in India tried to access an image, and that image was not available. So from the backend server, that image was being fetched and given to the user. Now, what cloud load balancing and cloud CDN does together is they are going to create a POP, point of presence. So what they are going to do is they are going to cache that particular image or that particular data in this POP. And let's say the next time a new user comes in and he is looking for the same image, let's say he's trying to get the latest image on the different cloud regions that we have. So instead of going to the backend server, he is going to be served from the POP location, and that creates a great customer experience. It gives a better return, the experience that has been created by Google Cloud. So that is CDN, content delivery network. So basically you're creating a network for content delivery. You just put the information there, the cache the information there, so that next time any user comes in, they are able to access it from the content delivery location. Cloud interconnect, you have your on-premise and you want it to be connected to GCP. Cloud interconnect is your solution. Cloud interconnect basically has two flavors. One is direct interconnect. Basically, if you are the end user, if you have access to one of the Google's data center, you will have a direct line to Google's data center. But this thing has conditions applied. Just keep that in mind. Now, let's say you are a user who is saying that, hey, you know what? I'm nowhere near the Google's data center location. What should I do? So that point in time comes partner interconnect. It's same, exactly same, but it's just that you have a vendor in between Google Cloud and you. So basically Google Cloud has a direct connect with your partner, and then partner interconnect can provide you connection. So they do the same for all the other, let's say this is your company. Another company comes in and says that, hey, you know what? I need a direct interconnect, but I'm not able to, so I need a partner interconnect with GCP. So they are going to ask that particular partner interconnect, and it's going to give them a direct line. All right. So this is what is cloud interconnect. Coming to cloud DNS, this is the one of the most reliable resource on Google Cloud at this point in time. It's being widely used worldwide, and this is DNS. We all know, you can simply convert your names into IP address, so that is easy for you to reach out to the right destination. The same thing is being taken care by cloud DNS. The best part about cloud DNS is if you are having internal machines that are on Google Cloud platforms, your machines will go through the backbone network of Google Cloud. There is a backbone network of Google. You don't have to travel through the internet, or you don't have to travel through the other telecommunications lines. No, there is a backbone line that you are going to travel through, and that's going to give you a better service. It's going to give you a better name resolution service. Okay, that's cloud DNS. Storage services. Cloud storage, I'll give you a brief example here about what exactly cloud storage is. Cloud storage basically means let's say I have a site, okay, but my site is something where people can come up, they can put in whatever they want. Maybe they want to put a picture of cat, the next time they want to put a picture of a dog. So this particular is a unstructured data, right? This is not structured. Somebody can come in and put a Microsoft Word document, whatever you want. So for unstructured data, we always recommend to use cloud storage. Cloud storage is going to take care of your unstructured data. All right. Now I'll just try and make it easy for you to understand the difference between Cloud Bigtable, Cloud Data Store, Cloud SQL, and Cloud Spanner. So Cloud SQL and Cloud Spanner this is relational database, relational, and this is unrelational, unrelated. Okay. What that means is, when I say relational, is like you must have seen database having columns and rows, name, last name, address, something like that. So everybody would have, their name, last name, address. So this is structured data. Okay, structured and unstructured data. So if you are having structured data, always go for Cloud SQL. It could be MySQL, PostgreSQL, anything like that. But if you're willing to have horizontal scalability, when I say horizontal scalability, is that in future you are not sure that how many users would come in and anything like that, and I want to make sure that I'm able to use cloud computing to scale my SQL servers, always go for Cloud Spanner. They are exactly the same. They are going to have your structured data. It's just that Cloud Spanner has horizontal scalability. That's it. Okay. For unstructured data, we have Cloud Bigtable and Cloud Data Store. Cloud Data Store, I'll give you an example what exactly Cloud Data Store is being used for in the current scenarios. It's used for user profiles. It's used for gaming purposes, because these are some unstructured data that we have. Okay, so this is what we are using Cloud Data Store for, and we don't want any structure from that, anything from the profiles or from the gaming profiles that are being saved. Cloud Bigtable, anything which is unstructured, might be possible that it's a financial site, that financial site, a fin site. Okay, it's a ad tech world site that I'm having. Anything like that goes on Cloud Bigtable. Okay, a quick brief. Cloud storage, for anything like pictures, images, anything you're not sure what your end user is going to upload, use cloud storage. For anything that is relational and structured, use Cloud SQL. When to use Cloud Spanner? When I need horizontal scalability, that's the time I need to use Cloud Spanner. Okay. Big data. All right. Big data is something, a huge chunk of data, and then it's being narrowed down and being used for analytics and other purposes. BigQuery is one of them. Take it as a warehouse for big data. Anything that you have, this is another kind of a data warehouse given to us by Google Cloud Platform. It is used for analytics purposes. BigQuery. Dataproc. So let's say you have anything around Apache. So let's say you have anything around Hadoop. This is the best thing. Just keep this in mind. If you have anything on Hadoop, go for Dataproc. If you have anything around Apache Beam, go for Dataflow. PubSub is asynchronous messaging service. So let's say I have one application dependent on another application. This application needs to tell application A needs to tell application B that a task has been completed. So for that scenario, I can use PubSub. So PubSub is basically a synchronous messaging service. That's it. Okay. Genomics and data. Okay, I'll give you a small example of genomics. So genomics is again changed to life sciences. So this is now known as life sciences. So we have our counterparts on medical research and everything. So genomics is something that is helping our medical researchers to just input their data and get the analytics result out of it. Now there might be a question. So I'll give you a small example. So let's say I am a scientist who is working on, great example, I'm working on COVID. Okay, I'm working on COVID-19. I'm trying to find a resolution for this particular pandemic that we are in. So all together, everywhere in the world, everybody is busy finding data, and they're trying to, but they're not able to sync their data. India is not able to communicate with America with XYZ, and they want that whatever we are researching should be shared among everybody. So genomics come in picture, or life sciences come in picture. You can simply input your data, share your data with anyone you are willing to, and genomics or life sciences is going to take care part of the analytics aspect. So it's going to give you the analysis of the data that you are putting in. It's just as BigQuery, but it's just that it's related to medical field. That's it. Machine learning. Google Cloud has a lot many machine learning aspects like Cloud Machine. So it has different APIs. Speech API, basically you can convert your speech to text. It has Vision API. So you must have seen some projects where people are scanning an image and it's simply taking out the alphabets from that particular thing. It has been recently released in iOS 15, I guess. So where if you scan an image, it's going to take out the data out of that particular image and put it as letters for you, alphabets for you. So this is the Vision API. There are multiple APIs, Jobs API. I mean, I'm not going to go in detail with all the APIs. It's just that these APIs are available so that we can integrate it with our code. That's it. Machine learning is very open source, so you can simply use these APIs from Google Cloud Platform and integrate it with your particular code to get the best results out of Google Cloud Platform. That's it. Moving on, identity and security. So Cloud Resource Manager is going to help you out with the identity and security aspect. Basically, if you are having a Google Cloud account, it's important for you to have an organization. So this is org. Under the org, you have a folder. Under the folder, you have your projects. And under those projects, you have your resources. Might be a compute engine resource, might be an app engine resource, might be a storage. So always try to understand any resource that you are using will be associated with one particular project. Okay, so projects are basically consisting of your all services that you're running. Folders are basically meant for, might be possible that I have two different working orgs. One is production, one is test. So I can create two different projects. One is production, one is test. I can have their own projects, I can have their own virtual machines just to take care of it. An organization is something, the organization. So let's say I'm a new guy, I'm trying to build up my e-commerce site. I have named it 𝐓𝐫𝐞𝐳. So that's the organization that you purchase when you're trying to create an organization on Google Workspace. All right, you don't need an organization if you're just trying to learn. You can simply start with projects on Google Cloud Platform. Cloud IAM, you must have heard it multiple times. Cloud IAM basically takes care about who can do what and where. All right, so this is what it is. Who can do what, where is Cloud IAM. So let's say I'm a user, so who are you? It's going to ask you. You can do what? It's going to check your permissions and where, on which resources. So that's the way Cloud IAM works. Cloud Security Scanner and Cloud Platform Security is basically, simply understand it this way: any data of yours, whether it is in transit or whether it's just idle, it is always protected by Google Cloud Platform by default. This is not given to us by all the other cloud vendors that we have out there. We need to take care of our own data, but with Google Cloud Platform, it is given to you by default. Whether your data is in transit or whether it's just idle, it is always being protected. That's the best part of Google Cloud Platform. And here comes some different management and developer tools. You have monitoring, just to take care of all the services that you are running. You can simply go ahead and monitor all the services like compute engine, app engine running at that point in time. If there is any errors generated, you can take care of the error reporting, check that errors, create a trace, debug it. You have your own cloud console, cloud APIs just to integrate with your code. Deployment manager, something like, I would say, Terraform. Okay, it's like infrastructure as a code for Google Cloud. Okay, so it's like some infrastructure as a code. That's it. Sorry, infrastructure as a code C. Okay, and so these are the different tools. You can simply go ahead and explore it later on when you start creating your account. And so that brings us to end of the different services, different management, developer tools, different storage, different networking, whatever we could have covered in an hour. We are already running a minute ahead of what we were supposed to. I'll quickly give you a demo. So this is my Google Cloud Platform. This is the site you guys need to hit, console.cloud.google.com. Okay. All right. Can we use PowerShell to manage the Google Cloud resources? Yes, I'm just, you can use PowerShell to manage the Google Cloud resources. All right, I will quickly give you a small demo on the virtual machine aspect. So this is on the left hand side. When you click on these hamburger icon that you see here, you simply go to the compute. Whatever we have learned right now, app engine, compute engine, cloud functions, Kubernetes. All right, everything is here. You can simply sit down and explore yourself. There are multiple services, as I said. Okay, so this is my particular Google Cloud project. So you can see here, this is my GCP project name. It is also giving me, what are the different resources that are running, how many storages I have created. All right, it's going to give you a good amount of information. And if you think you are overwhelmed with all this information, you can simply click here, hide a card, change your card, whatever you want, you can do that. Google gives you that ability. Okay, all right, go into compute agent, click on virtual machines. This is the best part, the practicals. I would always encourage everybody to go ahead and do the practicals. That definitely creates a difference. Okay, it gives you a better idea about whatever theoretical information that you have. Here you can see create instance. I'm going to click on create instance. And as I said, compute engine is a part of infrastructure as a service. So if you're on infrastructure as a service, you are allowed to take care of the operating systems and everything. So that's what I'm going to show you right now. So here is the name. I'm just going to keep it default instance 3. All right. So here I select what are the regions I want my machine to be. There are multiple regions. We always recommend to select the region which is near to your end users. Okay, whatever the application that you are running, once you select your regions, it's going to have different zones. All right, we selected a zone. Now here comes the different machine configuration that are available. General purpose, compute optimized. If in case you need 16 GBs of memory, 4 vCPUs, no, I don't need that now. Somebody comes and no, I need a memory optimized. So okay, so you have a memory optimized 1.4 TB of memory. Just keep in mind that whatever you are going to allocate, you are going to pay for it. Whatever you are going to run, you are going to pay for it. Okay, so for now I'm just going to go ahead and select a N2. It's a very simple basic machine. It has 2 virtual CPUs. It has 8 GBs of memory. That also I don't need, just for the purpose of showing you guys, I'm showing you. And it has a boot disk. So for the boot disk, I select the operating system. As I said, you have the freedom to select your operating system. You have the freedom to select from the different flavors of Windows to all the Linux operating systems. You can go ahead and select a SQL server if you want. I'll keep it as Debian for now. All right, I'll click on create. Now you can come here and see that your compute engine resource is being created. And the best part is, if it fails, it's going to give you a good error. As you can see here in the red, it's going to give you an error, like what exactly it is happening. All right, see, you saw the time it took to create a virtual machine. It's done. It's already done. Great. So I have the instance 3. I'll just try to take a SSH to it. All right, wonderful. You see this? Now you have a machine running on Debian OS for yourself. That's it. It was so simple. Okay, and as I said, always make sure whatever the machines or whatever the resources you are having, always try. I don't need this instance 3 right now, so I can simply go ahead, click on these 3 dots and stop this, so that if the moment I stop it, I'm making sure that this particular service does not use the resources I have allocated to it. Because whatever you allocate, whatever you are running, you are going to pay for it. That's the part of Google, but that's a part of cloud computing. All right, and keep learning. That's the best part. Whatever we have learned right now, keep practicing that. And I thank you everybody for joining in, for taking out time, and I wish that everybody stays safe and healthy. Take care of yourself and your family. Have a good one, guys.